Hi, so I want to show you how to make natural gas alarm. So you need one of this speaker. It works with 3 to 24 volts. It's quite loud. And one of this gas sensor. This one for the gas, it's model MQ4. Okay, so what we need is basically only these two. And I'm also gonna use, you see, a 5 volt, it's 2 amps, but it doesn't matter. You can use a half an amp, 1 amp, whatever. I cut the end, then I just solder two of these headers so I can plug them in here. Let me plug this into a socket. Okay, don't short this now. You see, first one here, it's VCC, so 5 volts. Next is ground, and then we have it's analog output and digital output. This sensor draws when connected to 5 volts, draws around 130 milliamps. I made the calculation and it's around 1 kilowatt hour for 2 months, so it's almost nothing. Normally you'd think that digital output will go high when it detects gas and low when it does not, but that's exactly the opposite of how this sensor works. And the analog is just the voltage on what it detects. If you just want the short version, if you want to connect a speaker, this is how you're gonna do it. So the plus to the VCC and the minus to the digital output. So we have this on DC voltage, and we're gonna measure the output of the sensors. So I'm gonna probe the ground and the analog out. Alright, so I have a lighter. So you see it goes right high when it detects gas, and now it starts to lower. So the analog goes from 0 to 5 volts. Actually, normally it stays around say around 1 volt. It goes like to 0.9 or something like that. Okay, so the digital output is controlled by this chip here, and the LEDs are connected as well. So it's an LM393. It's a dual op-amp. So this is how it looks. Basically these pins are not connected. This is the ground and this is the VCC, the 5 volts. It can take up to 36 volts from the datasheet, and they only use one of these op-amps, and basically they connect the analog output. They connect it to the minus here, and this one is the center of the potentiometer. So we have this potentiometer here, and you see it has 3 pins. This one is the minus, this one is the plus, and this one is the middle. How do I know? You can just put this on continuity and probe between the minus and these two, the VCC and ground, and you'll find out. Okay, and then you measure from the minus to this pin here. I'll show you in a second. So we're still on voltage. We're gonna probe the digital output and the ground. So now it's high, it's 5 volts. Just put a screwdriver in here and adjust it. Measure between this and this. 4.4. So why I set it to 4.4? Because the maximum will output 5 volts. So I put it from around 4.5. You don't want to beep all the time. So the second part, it's this part with the LED that turns on. So the circuit looks like this. This is the digital output. This is 5 volts, and this is the LED, 1K resistor, so it doesn't burn the LED, and 10K that stays like this all the time. So because it's a digital output, you must make sure it's drawn to low or high. So they use this resistor here, so it doesn't draw because it's connected all the time here. It needs to be higher. Basically what you do here, you just connect the speaker in parallel with the LED. So you put the plus to the 5 volt, you just put it here and the minus to the digital output, so exactly in parallel. And now we're gonna spike it till 4.5 and you're gonna hear the speaker. Alright, so let me put this function here, maximum. So the moment it reaches 4.5, we'll see it there and you'll hear. So you can see it actually triggers around 4 volts because these op amps are not perfect and there's noise and different things. I soldered this on the 3 pins, the VCC ground and digital output. I connected the speaker to the VCC and digital output. So we have VCC on the right and ground on this, you see. And this is just a USB cable that I had around. I just soldered it to this connector that I desoldered from some boards I had recycled. I usually keep for parts, whatever is broken. And it's plugged into a power bank. And as you can see, it's working right now. Alright, and the last step, we need to calibrate in a real life environment like the stove with the natural gas. So I've connected to the ground and analog out with these connectors with my voltmeter on measuring voltage. So basically just release a bit of gas, not too much, and then move the sensor a bit closer and you see it's rising and then it falls. And I'm thinking of maybe putting it around there. And you see right now it's going down. So you just need to do a bit of testing like this in a real life environment and then adjust it to trigger around something that's real life, because I've tested it with the lighter and it was going with the lighter right on the sensor around 4 volts here, but you see with just the gas from the stove it goes around 2. Okay, and after you figure out your voltage you want to trigger, you measure like I've shown you the voltage between these pins here. Alright, so after my testing I've set it to 2.1 volt. Basically this is the comparator. So once the level reaches around 2, it will the speaker will start to scream. Alright, and now to assemble it in a box. It's what I had around. It's just a kitchen timer, a mechanical one. It got broken, so I'm gonna use this because it kind of fits. So just stuck the speaker between these poles here. Used a bit of double tape on to stuck it here. I've used a bit of permanent marker to make the light a bit dull because it was too bright, and then flip this over. So we still have the red light a bit, but it's not glowing so much. Yeah, and something like this. Of course, if you find like a better box, this hole is a bit too big, it should be only this. You can make it prettier, maybe 3D print something, but for now it's gonna do it.